All right, good morning, everybody. Hope the keynotes are going well for you guys. Looks like everyone is finished trickling in. We'll get started. Thanks so much for being here today. We're very excited to be with you. This talk is about how UW Madison monitors 25 plus research clusters using Cilium and Prometheus Agent. We could not fit that all on the slide very well, so I kind of condensed it. So don't worry, you are in the right talk. Thank you so much again for being here. We are very excited to share what we're working on in Wisconsin. I am Ryan Etten, a senior architect and team lead at Red Hat. Co-presenter Cory and I here are pretty proud of this story here. It's very personal to us. We're both alumni of UW Madison, and we both back home run the cloud native CNCF local chapter in our community. So the solution that we'll talk about here today came from Cory's work with the university and is going to talk about some of the exact challenges you may be facing in your observability environments today. He was finding some of those real answers to tough real-world scaling challenges, and we'll talk about some of those hard-won lessons at the end. We both felt pretty strongly these lessons really shouldn't be left in that research lab. So, Cory, go ahead, take it away, get us started.
Cory from the University of Wisconsin. I've recently gone through a job change, so that made some rushing for the demo. However, very happy to be here. Now an AI systems architect with Clarative that is a healthcare technology solution and dealing with a lot of the same problems that I have recently dealt with. And to go with that, so the evolution with the clusters at the University of Wisconsin really started with a researcher approaching a developer for a restricted use case. We looked in Docker, so back then, Docker only ran as root, so that pretty much threw them out of the window. Kubernetes became the only viable option for this use case, and it really grew out of that. Not only did the use cases grow, the teams grew. We went from a very small footprint to a very large footprint, and out of that, an internally developed IDP spawned from that, as well as adopting more and more open source technologies. Some of the issues we ran into were the amounts of costs that were associated with observability. I submitted requests for purchase for a lot of observability solutions, and those requests were denied, but they would continue to put money into compute and GPUs. The reason why it ended up going with Cilium really came from a layer 3, layer 4 DNS requirement that we had to track. And then out of those capabilities, it was came the entire stack. So we were running multiple different CNIs. Calico was behind a paywall, and so we moved to Cilium to deal with that DNS requirement. And then it really spawned from there, where we got layer 7 observability. We were running Istio at the time, but then we continually migrated to the mesh and gained some more use cases. So the design principles, these were research clusters, and the researchers are very cognizant of their compute, so it had to be extremely lightweight, removing the sidecar tax. The centralization needed to be centralized. The operational overhead of running Prometheus on all of the other clusters became too great, so we looked into the centralization with those metrics based off of this solution. And it needed to be self-service because we couldn't deal with the operational overhead of the amount of all of the service monitor, all of the observability requirements. It needed to be extremely streamlined, and with the transparent encryption and workload identities, it became self-service through the IDP. And it must be open source, as at the time our request for purchase was really, we didn't have any options. Our options were to build our own or just leverage community tools. And so we ended up leveraging the community tools. The winning combination ended up being the eBPF with the layer 7 observability, the cluster mesh that came with it, and the Prometheus Agent that would forward it to the central cluster. We made it extremely modular. We found a large reduction in some of the operational overheads from running all of these clusters into one. And the remote write protocol that centralized everything from all those other clusters.
All right, thank you, Cory. Okay, I'll sit on this slide just a little bit here. So overall, this is kind of where everything kind of comes together. This is the architecture that was deployed. Key idea there was very simple: stop paying that sidecar tax. So instead of injecting a proxy into every pod, there were 2 small node-level agents. So in every remote cluster, Cilium ran as a daemon set, and then Hubble enabled that layer 7 visibility using eBPF directly in that kernel. So that was 1 agent per node, not 1 agent per pod, and that is what helped us reduce all of that extra overhead. Next, Prometheus Agent, or Prometheus was run in agent mode, so it's stateless. It went and it scraped all those layer 7 metrics. It applied pruning, immediately did remote writes. There's no local time series database or any storage footprint. And there was also a compatibility Prometheus that was scaled to 0 for any tools that might still be looking for a particular API. All of those agents then send their metrics to the central cluster. That's the single pane of glass. It's the only place where all of the heavy tools were running. That's Prometheus, Grafana, Alertmanager, and Hubble. The Hubble UI was still deployed to all of the clusters, though. And then the magic that brings all this together is that Cilium cluster mesh. So it formed that multi-cluster network fabric, and when it's encrypted, can secure everything across all of those clusters. In the central cluster then, Prometheus was exposed as a global service, marked by that annotation of service.cilium.io global is true. And that gave us a consistent DNS name then to resolve and make the visibility available to every cluster. So all 25 Prometheus agents then pointed to that single URL, and there was no juggling of IPs or any load balancing that needed to be done as well. Most importantly, we'll unpack a little bit later some of the lessons that are there. We learned a few big pains when it comes to pruning high cardinality metrics there. We made sure a lot of junk never hit the wire, and we also tuned the remote queue there, the queue config, so that the connectivity returned after an outage, and it didn't actually essentially give it a denial of service attack back to the central server. So overall, this is how you build that lightweight, scalable observability platform using eBPF, Prometheus Agent, and Cilium Mesh. I'll hand it back to Cory to start to give us a look.
So some of these prerequisites, the kube proxy add-on being disabled, you can obviously remove the kube proxy once the cluster has been built, but then when you go through upgrade processes, it will come back. So just having that skip phase kind of removes some of the operational overhead there. And then there is the service CIDR requirement to be all unique, so that none of the clobbering or any of the traffic gets conflicted with other clusters. The network planning kind of follows that same line, making sure that these CIDRs are separate at the service layer, and then this works in a flat or non-flat network, regardless of the host networks or the other networks. Some of these values came through some hard-won lessons, but obviously, we need the Cilium Mesh enabled true. You need unique names and an ID. I think the default comes with 0, but you need to make sure that all these clusters are uniquely named and uniquely identified. The auto method is Helm. That way, there's no CLI interaction to get these up. You have the entire configuration kind of at the embedded into these clusters. The kube proxy replacement true. I did miss something on this slide, and to get the L7 observability, you need the L7 proxy enabled as well. And that should get you pretty far. The auto mode, the authentication mode cluster. So I relearned that lesson on Saturday. It came with the default legacy, but that cluster and the kubeproxy needed to be enabled. I couldn't get it functional in the demo environment. I was like, oh, okay, I forgot about this one. But those two are pretty important. Some of the key configuration snippets. So the services that are going cross cluster need to be annotated with that global true. The agent service, as well as the agent service, the Prometheus service that the agent leverages, and the central Prometheus service. The central configuration cluster with the enable remote write. A little later, there'll be another slide that talks about the send write. And one of the big things was this decoy Prometheus deployment that was required because of some of the configurations with the Prometheus kube stack. I'd spent some struggles with that one, but this decoy deployment is what provided that capability. And now into the terminal. So we have some of the commands on the right, and right now we're going to be running. So this will showcase the cluster configuration where you can have any number of IPs. We're using node port in this example. It can be a service and routed through the load balancer. But these names, that's where your entire stack of your clusters are, and then you can have multiple IPs where those clusters go, and confirmation of these, just showcasing, hey, these clusters are connected. That global service that's being provided is what's allowing the traffic to run through. Here's confirmation on the cluster connection with the second cluster with the global service, showing that those multi-cluster routing is capable. Right here, we are tracking, just providing confirmation that there are no sidecars, and the second cluster's running the Prometheus agent. Right here is the command of getting the service list. In the second cluster, we can track the 9090 protocol going to the Cilium endpoint 10.0.0.196, which should be in the other cluster. And right now we are looking at that endpoint 10.0.0.96. Apologies, it went a little fast, but that's confirming that, hey, that endpoint is on that other cluster, and that's how the traffic gets routed. And here is the service list for the main cluster, and the 9090 is there as well. And these are the, sorry, let's go one. The endpoints in the external cluster, showcasing that that service is not listed, that endpoint is not available in the external cluster. And then additionally, now we're getting into some of the relabeling requirements. So when the central cluster needs these relabelings, otherwise you don't get any of the metrics. You'll get all the metrics from all the other clusters, but you lose all your metrics. So the relabelings of all of your service monitors or all your metrics really need to be relabeled for that cluster label. And then continuing from there is when we just annotate, hey, this is the central one, and now we're tracking both clusters. And if we look here, we can showcase that, hey, this isn't running sidecars. We're only running 31 and 280 megabits for the entire mesh. So the analysis from the sidecar to the this solution is outside of my memory at this point. It's been a little while, but this is just to showcase that it is saving a lot of compute resources. And then here is the network policy that's being enabled for layer 7 routing. So this is what is committing the alert or any of the really required to grab those layer 7 traffic. Without that, you don't get it. And right here we can see Cloud Native Madison layer 7 demo. This is where that alert is being tracked. And right now we just generated traffic. And if we go back, we now have our alert for that layer 7 observability. And we'll go over to Hubble. We can see, the observability and the traffic being denied right here, as well as some of the allowed ones. And then after this, I'm not sure how familiar everybody is with Hubble. There's lots of tools. And then it just showcases another observability, visibility layer, just to kind of see all of the traffic there. And we can see the external Prometheus agent from the and I think that was it. Some of the hard-won lessons, somewhere between version 13 and version 15, the Hubble relay was really causing me some pain in regards to its authentication. I spent a decent amount of time trying to figure out what was going on. I just ended up figuring out, I figured out restarting it would typically work, but then I went into the configuration and just, hey, anytime a config changes, do the rollout restart, and that saved me a lot of headaches. Some of the other components with the Cilium enablement versus the configuration enablement, I spent a lot of time trying to get some of those up. A lot of the documentation was a lot of CLI based, and just based off of my own configuration and how I was deploying this. Once I just switched to a completely Helm configuration, pre-configuration, it made it scalable and extremely simple. And the dashboards leverage some of the monitoring stream for some of the event flows. I didn't have any access to that in the beginning, and the execution of that now provides me that where I was missing it prior.
All right, with about 5 minutes or so to go, thank you, Cory. These are pretty dense slides. We only had limited time, but I want to leave you with some important stuff here. If you guys are new to Prometheus or even on your journey, you all know that metric cardinality explosion is something that you're probably going to run into. So when it comes to the mesh, you're going to get a whole bunch of metrics that you really don't need to capture. And so on the left-hand side there was just some of the issues that they had run into, and then a prom query you can run to kind of figure out in your environments what the top 10 noisiest metrics are. And then as you start to scale, break those out into 3 different phases. So that first phase, we want to enrich that data. So since we're working in a mesh, we want to make sure that we label everything that's going to be going to the central server, add a cluster label to that. Then that's going to be fed into the next phase of where we aggregate and create some recording rules. So then we figure out which jobs that we want. So instead of, we have HTTP requests. So instead of saying, send me 1,000 sales receipts, send me the sales total after 30 seconds. That's essentially what we're doing with the HTTP traffic. And then adding that label to it. And then that's with the metric relabel config. So that is all with the write-ahead logging that's there. And then when we're ready to ship that off, that's when we switch to our write config as well in the third phase and start to prune everything and drop that traffic, or drop those labels that we don't need and send just the aggregated logs and metrics according to those clusters. And then, are we almost out of time? Keep going. The next one here, another thing we ran into a split brain issue with a TLS cert. So here's some recommendations for you on how to tune your configs. Look out for some gotchas. Prometheus by default will have max shards at 200 instead of 5. So when you start to figure that out, you have maybe up to 10,000 connections, with 25 agents. So by dropping that down, we only have 250 connections then. Marry that up to the max samples per send of 5,000. So essentially we switch from a 1,000 vehicles on the road to just kind of building up just more trucks, filling those capacities and sending them down back to the central server. I think we're good. All right, payoff? Yeah, you're good.
Payoff is, with all this pre-configuration, saved a whole lot of overhead. And instead of spending times with, days and getting these clusters connected, it was almost instant. And one cluster to rule them all. Cost nothing, which made management extremely happy because without all of my headaches. But it was very cost effective. Researchers love their money. Don't like me taking it. How's that? And then the final playbook. There's prep work to get these clusters configured, make sure you have those unique CIDRs. We can get the layer 7 metrics for free, and it makes the networking, I won't say it's easy, but once it's all set up, then it gets very, very routine, and part of the IDP gets deployed. New network policies can go up pretty instantly. The remote write to get all of those metrics centralized, and you get very deep information with those clusters. Those right.
Yeah, and then just enrich those metrics, prune for aggregate, tune for those convoys, monitor the monitor. A few slides back, I did not get to it, but there was a command in there to see and warn yourselves before everything starts to fill up in the queue. And I know we're close to time, so any questions before we get going? Yes, over there. Yes, I can hear you. Yeah, if not, there's a microphone over here. As she makes her way over, little plug. So as I said, we are with Cloud Native Madison. There's a lot in this deck here today. We'd love to continue the conversation. So we will be on the Solution Showcase floor for an hour and a half on Wednesday morning. Please stop by. We would absolutely love to talk about where you are in your journeys and kind of take this and unpack it a little bit more. All right, go ahead.
Hey guys.
Hi.
Hi. My name is Kirtana. I'm a DevOps engineer at the University of Michigan. So I know you mentioned that you had some budget constraints when you were evaluating other commercial platforms. I wanted to ask, if the budget constraint didn't exist, is there a reason, or is there any other features where you would prefer other commercial platforms over the open source implementation?
That's a great question. You want me to sell a platform or sell a solution?
No,
if there wasn't a budgetary constraint, anything that provides the same solution with less overhead, I'm really indifferent to many of them. I did the request for purchase for 3 of them, and I need the tools, so I just need to be able to have the information I need to do my job, and where that comes from, I don't have much of a preference as long as it's there.
Yeah, thank you. The reason I was asking is we're also sort of those crossroads where we are trying to evaluate different tools and understand the overhead that comes with each tool, which is why I wanted to know your input as well.
So in general, in the fight of build versus buy, the amount of information I gained from going through this process has been really instrumental in my career, and I'm very thankful that I had that opportunity. However, there's many ways to just gain insights. But at this layer, it was phenomenal. So those are hard decisions that you have, and it's across the board.
All right, thank you. Yeah, thank you.
I think we're out of time. Yeah, really good question. Yeah, other solutions like Datadog and everything are out there as well, but I think this is just a really good example of diving into the open source ecosystem and proving that this is a productionalized solution for a fleet of research clusters. So
Yeah, we're also trying to understand what's the right fit for us. So this is interesting. Thank you.
yeah, wonderful. Yeah, let's talk more. All right. Well, thank you so much, everybody. Enjoy the week. Stay warm. I think it's getting to 70s by the end of the week, so that should be nice. All right. Thank you.